you've got another set of calculations that you have to do. And if it's got a mixture of things in there, then you've got yet another one to do. So you've taken a look at what you knew was your residual risk before, and you have to determine, has my residual risk changed? And if it has, what do we have to do to get it back to that same level of acceptable risk to the designated approving authority who's going to sign off on the system as being operable? Helps if I hit the right key. Along that same line of the certification accreditation, if I can get my accreditor and my certifier involved early on, then I can train him in thinking the way that I'm thinking, and I can help I can understand what his thinking is. But don't rely on that making your job easier, because that CNA authority or designated approving authority will have changed 3 times by the time you get from system design to the time you get to this particular point, and you will have had to train up 3 other people or 2 other people. And documentation, documentation, documentation. More documentation. There's a number of levels of certification accreditation that you can go through. The DoD and the intelligence community in the United States have started to get together and said DICAP, DITSCAP, and some of the other common criteria and Orange Book certifications that we've had to go through in the past is too many. The Office of the Director of National Intelligence has said, get together, we're going to have one certification and accreditation framework. And of course everybody said, that ain't going to work. And so now we've got the overall document, and now we're going to have implementations specific to particular customers. But at least there is now the hope that it'd be more uniform when working towards the certification for the government. Commercial world, there are probably as many ways to certify an accredited system to get it online as there are customers. But one of the certifications, put quotes around that, that you may see is something called a SAS 70. And this is an accounting standard document that says that somebody has reviewed this and they believe it to be, they've reviewed your documentation and your processes and how you got to where you are, and they believe that to be good and true. Doesn't necessarily mean that it'll operate as you say it'll operate. And now the final phase, which is the transition to operations, and then the operations and maintenance phase. So when you're designing in the early part of the system engineering lifecycle, you have to consider how the system is going to be used. Who's going to use it? The skill level of the operators, the skill level of the managers, the skill level of other kinds of users. Is it an internet-facing system? Then you have to assume a skill level of near zero. If the great public is going to be, if your grandma is going to be the primary user of this system. If it's a video game, there's probably a different skill level. Now we start exercising things called disaster recovery and business continuity of operations plans. So if you've designed it well, then you know you've got a backup system, and you know the backup system will work, and now you get to prove it. During operations and maintenance, some organizations kind of give just a lip service and a quick passing kiss to the disaster recovery plan, and then something happens and they're essentially out of business for a period of time while their system recovers. We can think of this past winter on the East Coast. The amount of snow on top of some buildings caused leaks, which caused systems to fail. And if there were no backup plans, if there were no continuity of operations facilities, then some companies may not have been able to, or were not able to, operate for a period of days while snow melted and cities cleared the streets. We need to figure out how we're going to monitor the performance of the system, and in our case, particularly the security performance. So a firewall that we install today is not going to work as a firewall that we install tomorrow. In fact, maybe we don't even need a firewall tomorrow. Maybe we need something else. Plus, we have to pay attention to what the new risks are. So we just upgraded from Windows Vista to Windows 7 on all our user interfaces. What are the new risks to that? How do we resolve those? And then, how do I get rid of the system? Okay. Terabytes of data. And I want to move all this data off this one platform to another platform. What do I do with the hard drives? Do I want my hard drive to show up on eBay with all my privacy information or all my design information that's available for whoever bought it to find it? So we talked about these. So in the process of this system engineering lifecycle, you're going to have lots of things in your toolbox. And what you select to put in your toolbox is going to depend on a number of things. Who you're working for, what your job is, what you're comfortable with. But consider tools for the design and architecture. Consider your tools that you're going to be doing for risk management, vulnerability analysis. What kind of tools are you going to be using to monitor your systems? And I'm not making any recommendations. So, you as a system security engineer have a role in all aspects of the lifecycle process. I hope I've proven that to you. You all already are believers in system security engineering as being important, and we now see how we can enable a number of functions all through the systems development. We hope we have well-defined processes, and we hope we are continuously improving those processes. We work to continuously improve those processes. Requirements, engineering, design, architecture all have approaches that we address throughout the system lifecycle. And at the end, before we can get things going, we have to figure out that we've actually considered all of the aspects of the requirements and the operations, disposal, disaster recovery, so on and so forth, before the system is turned on. So, are there any questions? Yes?
When you're talking about functionality testing and accreditation, the aspect of accreditation that you're talking about, how do you verify a certain application that you develop? Is it based on a security level, or is it based on, the qualitative analysis of the unwanted functionality or the quantitative analysis of the unwanted functionality? I mean, how do you evaluate that the software is safe enough so that you can implement it in the production environment?
If you've developed it yourself, you have access to the source code. If you have access to the source code, or you can require access to the source code, you can start doing you can use some source code analysis tools to determine that there's not unwanted functionality in there. But Microsoft is not going to give you the source code for Office. Apache's you are going to be able to get the source code for the firewall, like the Tomcat firewall or something like that. So you can do an analysis of that. You can also install it and beat it to death, and to see what happens when you stress it, or when you exercise the attack vectors that you expect that your adversary can use to get to your system. So you can do those in small bits and pieces, and then you can aggregate it together. If you've got enough money and time, you can then test a larger system. Source code analysis is probably the best but hardest piece to do. You can also rely on other people's testing. So we have something in the United States called the common, or in the Western world called common criteria. So Germany, England, France, United States, Italy are all signatories to the common criteria. And then there's levels of common criteria. There's level 1 through level 6. And level 1 security targets are pretty basic. Level 6, there's been a formal analysis of the product for covert channels, and so there's quite a spread between these two things. But in order for it to be evaluated at common criteria, somebody has written a security target. They say, this is the security aspects of this system, this is what it's supposed to do, this is the target that we've gone. And then there's a performance evaluation by some outside organization that has evaluated whether this product meets its target. And if you had an EAL4 evaluation performed on a particular product, you've written the security target, some common criteria lab evaluation facility is going to certify that you met your target. So somebody then takes your product and says, oh, I want to use this widget that was developed here. They're going to go look at the security target and say, oh, that's not the same security target I had. Guess I'm going to have to go look elsewhere. Or they're going to look at it and say, close enough. Or they're not even going to look at it and just say, this was the AL4, we're going to use that. But the good engineer will look at the target and say, yes, it met it, or no, it didn't, and if it didn't, then they may want to take it through an evaluation to meet their target. Did that answer your question? Any other? Dan.
Steve. That second to the last bullet, I think, of course, is very interesting. I was wondering, in your experiences, perhaps, if you can comment on. Oh, sorry. If you can comment on whether the system security issues come in as constraints or parts of the objective function, and are they sort of, does the program manager or someone else who's worried more about performance try to avoid them at all costs until forced to deal with them?
Yes.
Yes.
Yeah, I have seen the last, and actually that probably was more common a few years ago for program managers to just kind of wave their hand and say, we'll solve that problem when we come to it. Because of the heightened awareness of cybersecurity issues, and because of the increase in the threat and the vectors by which that threat can be realized, people are realizing that they have to identify and mitigate some of these risks earlier in a program. There's been some spectacular failures, as you're well aware.